Okay, so you should be here to practice the last two things from the slideshow, which is balancing chemical equations and identifying types. We're going to do the first three, and then I'm going to give y'all 7 to work on because this tends to be a topic that we need a lot of help on. So you're going to have 7 examples to work through and to hopefully help you learn the system yourself. So when I do balancing chemical equations, I keep track. So I do something like this. And I count how many atoms I have on the left and the right. I have 2 nitrogens and 2 hydrogens. I have 1 nitrogen and 3 hydrogens. And so I can see kind of what I'm working with. I know I need to increase the number of nitrogens, so I'm going to put a 2 in front of the ammonia so that now I have 2 nitrogens, but the 2 times the 1 and the 2 times the 3 means now I have 6 hydrogens. So now while my nitrogens are balanced, my hydrogens are not. But fortunately I can see that 2 and 6 are related by a factor of 3. So if I put a 3 in front of this, well now I have 3 times 2, which gives me 6. So now they're balanced and everybody's balanced, meaning there's only 1 in 2. If I do the next one, I have, let's do a different color. I have KClO, 1, 1, 3, 1, 1, and 2. So there's 1 potassium, 1 chlorine, 3 oxygens, 1 potassium, 1 chlorine, 2 oxygens. Now, my potassium and chlorines are both balanced, but my oxygens are not. But when I have this relationship of 3 and 2, they don't have a common denominator. So normally what I can do is I can put a 2 in front of the one that has 3 and a 3 in front of the one that has 2. And this sometimes is the trick because now I have 2 times 1, 2 times 1, 2 times 3. And over here I have 3 times 2, which is 6. And so all I am missing is I need 1 additional potassium and 1 additional chlorine. And conveniently, if I put a 2 in front of the potassium chloride, now I have 2, 2, and 6. And so this equation is balanced. So make sure you look out for that relationship of 3 to 2. It shows up quite a bit. And normally the trick is, just like you saw up here, factor of 6. It's a common number between them because when you multiply 2 times 3, you get 6. So the next one is sodium, chlorine, fluorine, and then sodium, chlorine, and fluorine. I go in the same order no matter what because I don't want to mix up and look at the wrong one. Okay, so hopefully you're starting to see the rhythm in counting these. Now I have 2 fluorines, 2 chlorines on opposite sides, but only 1 on the other. So if I put a 2 in front of the sodium chloride, now I have 2 sodiums, 2 chlorines. If I then go out to balance the other side, 2 sodiums, 2 fluorines, now I have 2, 2, and 2, which makes my equation balanced. Okay? So practice the other 7. You need to have them complete before you submit your assignment. So now what we're going to do is we're going to classify the reactions above using redox, synthesis or combination, decomposition, single replacement, or double replacement. The only one that's not here is the ion exchange because the ion exchange you need to have whether it's forming a solid, water, or a gas. So that one's not on here, but the other ones are, and that should be enough to help you. Okay, so I'm going to write the identity of the equation out to the left-hand side. You can do the same if you want to, or you can just type in 1 through 10 and submit that after question number 4. So when I have nitrogen plus hydrogen making ammonia, I am taking A plus B and making AB, and we call this combination or synthesis. On this hand, I have A, B becoming A plus B. It's breaking apart. This is decomposition. It's the opposite of combination. My next one is AB plus C is AC plus B. And hopefully you can see here that this is A and B dancing together. C comes along, displaces B, and is now dancing with A. So this would be a single replacement. Now, when I was in your shoes having to identify equations, I always started with synthesis combination first. I looked for it, is it this? Okay, if it's not, well, is it decomp? Okay, is it not? Then I looked for single replacement, double replacement, and the last is if it's not 1 through 4, it's probably a redox equation because you can't see the electrons moving around. So if you identify that it's not synthesis, it's not decomposition, it's not single replacement, it's not double replacement, it's most likely going to be a redox equation, at least in the context of this class. Okay, so you have 7 chemical equations to balance and 7 to identify on your own before you submit this back to where you see the assignment that you downloaded.